Yes, I did ask for the slot right after food because, yeah, exactly, right, something like that. Okay, anyone who still wants to snap this, do it in the next 3 seconds. 21, 22, 23, and go. So I named this talk, We've Got the Tech Now, What About the Skills? This is a bit of an adaptation of a longer talk that I did earlier this year at the Open Education Mini-Conf at LinuxConf AU in Sydney. At the time, this thing was about sort of general education in a professional context and so on. And the thing that I wanted to talk about in a little more detail, and this is something that affects us at Citi, I'm sure it affects many of your companies as well, is that when we look at distributed technology, let's call it this, because just about any technology that has emerged on the market in the last, shall we say, 10 years is really only interesting because it is massively distributed in order to achieve elasticity and scalability, right? It doesn't matter whether we're talking OpenStack, whether we're talking Kubernetes, or we're talking Open vSwitch, whether we're talking Ceph, whatever. Just about any technology that's really interesting is distributed, and that adds a great degree, I would say an order of magnitude of complexity for these technologies. So the question that we could ask is, what is the typical major challenge that most companies face when we want to deploy these technologies? So for example, it could be a question of cost, right? So cost as in simply spend less or make bigger margins. It could be questions of scalability, that is the ability to start small and then grow really, really fast as your customer base grows. Or it could be speed, like time to market, as in developing prototypes, taking those to a minimum viable product, taking those to production solutions, launching those on the market, starting to make money on them. And that's quite sensible, right? To assume that those things would be the top challenges because, after all, cost savings and scalability and speed are mostly why we want to adopt these technologies in the first place. But when we talk about what the most important challenges that are associated with a lot of distributed technologies are, it's neither cost nor scalability nor speed, but it's a problem of skill. It is the challenge to actually have people who are competent enough, who are trained enough, who are well versed enough in these technologies to be able to run them, right? And of course, these technologies are all new, or most of these technologies are very new. So of course, a lot of the people, let's put it this way, the people who are already very well versed and very experienced with these technologies are quite rare. And quite frankly, they're quite expensive as well. But we want people to know and understand these technologies, so why don't we actually train them? Why don't we enable them to do exactly that? Why don't we enable them to grow their skill sets? And why don't we train them in a way that is itself cost-effective and scalable and fast, in a way that works in distributed teams, which are becoming more and more prevalent in our industry as well. And now, if we look at the way that we commonly do training, the way that we commonly allow our people, our colleagues to acquire these skills, we find out really that the conventional methods are really not a great match. Because, okay, so one thing that we can do is we can pull a team, we can pull something like 10 people out of their respective projects for a week, get them all to the same place because they might not be working in the same place, then fly an instructor in, something that takes maybe something like 4 to 6 weeks lead time, and then actually get them together in one room and try to cram as much knowledge as we possibly can into them in something like 3 days. That's not great, right? That's not a great way of doing things. So most of the time, people say, "Oh, well, we can we can decouple the whole training bit and the skill building and the skill acquisition bit from place and time if we allow people to train online, right? Okay, fine. And then that means that they normally listen to a talking head, right? They watch a video of someone talking about something, and I see some of you here like cracking a weary smile, which I interpret to mean that yes, I've been through this sort of thing and it sucked, right? And that's sort of the typical way of how most companies like approach this sort of thing. Most training companies approach this sort of thing too. So it's like you're listening to a talking head on a video, and then the rest of the gaps that still remain, you should fill through self-study, right? From documentation or whatnot. How silly this is becomes evident when we compare it with something else. Like, say for example, if we're putting people through training like this, and then we're expecting them to be able to actually manage a very complex application structure that runs in a public cloud, or manage Kubernetes clusters, or manage a Ceph environment, or something like that, that's a little like taking astronaut candidates and then putting them in a lecture hall with a bunch of books and perhaps a few tabletop exercises, right? And then dragging them out of the lecture hall, strapping them to a rocket ship, and then sending them into orbit without ever having set foot in a simulator. I don't know what you call that. I call that a broken model. I don't think that works. And I think we need something better. We need training environments that actually help you learn what you want to learn, training environments that enable you to actually immerse yourself into the technology that you are, where you want to acquire some skills, training environments or platforms that enable you to interact with your peer group just as you would if you were seated in the same room with them. And then of course, because I'm an open source guy, I want this whole thing to run on an open source platform, not just because it's a philosophy that I subscribe to, but because open source simply innovates faster than anything else. And so the way that we built this is with a learning platform called OpenEdX that is originally came out of MIT, Harvard, and Stanford. It is now one of the largest learning cooperatives essentially in the academic world. And this is the entire platform is itself open source under the Affero GNU public license, so anyone can run an OpenEdX stack. We do that. This is something where we're sort of helping OpenEdX make inroads into professional education. Funnily enough, the first major corporation, as in not a university, that got itself involved in OpenEdX very, very strongly in the United States was no other than Microsoft. Right? So there's others who are waking up to this as well. And we can use OpenEdX in combination with OpenStack. Right? We run an OpenStack public cloud. We run our OpenEdX environments on that public cloud as well. We train our own people on that sort of thing. We make it available to our customers. And we do it in two ways. One, we're running the learning management system, the OpenEdX environment on OpenStack itself. And we are making arbitrarily complex lab environments, actual realistic training environments available to all of our learners. And we use OpenStack for that as well. So that gives us the opportunity to, say for example, if we're building a Kubernetes class and we want to ensure skill building for our own employees or for our customers on Kubernetes, every single learner gets a Kubernetes cluster that they can actually play with. And I really mean play with. This is really important. You want to be able to work on a virtual environment that you can break with impunity. You want to know, you want to understand how to break things or what things look like when they break. And that's why virtual lab environments become crucially important, because very often doing that on an actual hardware environment becomes very costly. And so you totally want to do that in a lab environment. Same thing for Ceph. Someone who learns Ceph should be able to play with a Ceph cluster of their own. It doesn't help to have like just, I don't know, whatever, a few virtual box instances. You actually want to work on a cluster. Same thing for Hadoop. Same for any kind of distributed technology that is where the skill is actually worth acquiring. And so with that, we think we have actually achieved a platform that is cost effective, that is scalable, and that is fast. And we can do all of that with open source technology. Why did we choose those specific platforms, or why did we choose those specific building blocks? Why OpenEdX? It's an open source project. It has a vibrant community. We like the technology. That was simply sort of personal preference. There is a contender in that same space, which is Moodle. That's a PHP code base. OpenEdX is a Python code base. That is simply something that we're more familiar and comfortable with, so that's what we like. And OpenEdX has a very nice extensibility framework, basically a framework of extension plugins that you can write for OpenEdX, which are called Xblocks. So we like that. Why OpenStack? It is open source. It has a very large and vibrant community. It is Python-based. We like the technology, and it's very extensible. You may notice a pattern emerging here. And so we combine those things together. So the ability to run OpenStack virtual environments directly from OpenEdX. So every learner gets a cluster of their own to play with, whether that's a Kubernetes cluster, a Ceph cluster, or for that matter, an OpenStack cluster. It's absolutely easy to do that sort of thing, to actually run an OpenStack environment within OpenStack and use that that way. There is something that comes in very handy here, like why are we specifically using OpenStack for this sort of thing and not AWS, and why not the Google Cloud Platform, which is that we can spin up these learner environments on demand, and when they are not in use, we can automatically suspend them. So we can basically freeze them in place, not use any computing resources, and bring them right back up when the learner comes back to that specific lab that they were working on. And that is a big cost saver, because if you want to imagine something like, okay, you want to teach someone Ceph, right? And so we're talking about a Ceph course that has something like anywhere between 22 and 25 lessons. And of course, you don't want people to cram that, right? You want for people to take one lesson at a time as the rest of their normal duties allow. And you want them to be able to reflect on those lessons that they took. So you don't want to be confined to this, okay, we have to cram everything into 2 or 3 days, which is what you normally get when you're working with an instructor and with face-to-face training. And now for those 20 lessons or so, the general expectation is that the learner will take about maybe a month. And then, of course, if you were providing that virtual environment to them for an entire month, then the course would become very expensive, because you would need to provide these environments throughout. By only running them when people are actually interacting with them and suspending them when they're not in use, that makes it much more cost effective. It's also easier on our infrastructure. So Heat helps us there in a big way. Heat is the orchestration component in OpenStack, which we do support in our public cloud as well. So it's basically every student gets a stack, and we suspend this stack when it's not in use. And very importantly, we built the whole platform such that the only thing that is actually needed to interact with this whole thing is your browser. So we've got terminal windows that are built directly into your web-based experience. We use Apache Guacamole for that. That's another great open source project where you get to interact either with a terminal or with RDP or with VNC. So basically, this can be applied to Linux systems, Windows systems, anything. It can be a terminal environment. It can be a graphical environment. That's entirely up to the course author. So the only thing that you need is a browser and an internet connection. The irony is not lost on me that one of those criteria is not fulfilled at this time right here. As with Masood, I unfortunately can't give you a live demo here. Like everything, all that you need is like literally just your browser. Any modern browser will do. Chromium, Firefox, whatever, Edge even, and you get dropped right into these lab environments. A cluster will spin up automatically for you. It will automatically suspend and resume for you, and then you have a very, very immersive learning experience. So that's basically sort of the combination of OpenEdX and OpenStack, which we do consider kind of awesome. It's something that helps us give our own people the option and the opportunity to learn pretty much any skill that they want to learn that we do have a course for, and we have a few at this point. And of course, all of that is itself, all of the various bits and pieces are themselves open source, including that X block that I mentioned, including the edX configuration bits and so forth. So OpenEdX goes to great lengths to not only make the platform open source, but the entire deployment automation. There's a whole bunch of Ansible playbooks. We've written a bunch of heat templates so you can run your OpenEdX on OpenStack and so forth. So you can take a look at that, and I have my laptop here with me, so if you want to see me after for a demo, provided that we get network connectivity going somehow, you're certainly welcome to shoulder surf and try your hand at this yourself. I'll be more than happy to let you take a look. All right, thank you very much.
Thank you so much.